Hello, I'm Landon Schlungen, and today we're going to do the JavaScript algorithms and data structures projects on FreeCodeCamp. Last time we did all the intermediate scripting challenges, or we did the last 6. These new algorithms and projects, they are a lot like the intermediate algorithm scripting challenges, except they're a little bit harder. We're going to be making a palindrome checker, Roman numeral converter, Caesar's cipher, telephone number validator, and a cash register. So let's start with the palindrome checker. Go to the first lesson. Palindrome checker. So palindrome is a word or a phrase that's the same forward as it is backwards. So in the case of race car, it's spelled the same from left to right as it is spelled the same from right to left. We should ignore underscores and commas and periods, but they will pass other symbols like star and hashtag. So to start this one off, we're going to have to get rid of the underscores and the commas and periods, as well as make everything lowercase. So to do that, we'll have string equal to string.replace, and we'll do a regular expression here and turn it into nothing. So this will get rid of the commas and the underscores. It'll be backslash uppercase W or with a pipe and then underscore. And then we want to make it lowercase. So just do dot lowercase, 2 lowercase at the end. So that will make our string better. Now we want to actually check if it's a palindrome. So we'll start by grabbing our end character. So we'll just have a variable called let end equal string.length -1. So that's the end index of the string. And then we'll do a for loop for let I equal to 0, I less than string.length, I++. So this for loop will start at the beginning and then go over one until it gets to the end. And then we want to do if string end does not equal string of I, then return false. So if this end character, so if E does not equal the first character, so this E, then return false. We can also do divided by 2 here, string.length divided by 2. Although I don't even know if we need that or not. We could probably get away with not doing it, but it's actually faster if you do divided by 2. But yeah, we also want to decrement end every time, and then otherwise return true. And I think that's all we have to do for this. Console.log I is true. I'm going to try getting rid of this divided by 2 here. It's still true. If we have it as EYYE, it's still true. If we have it so that it's false, then it'll be false. Overall, I would say checking palindromes is pretty simple, pretty straightforward. Just compare the 2 outside letters first and then make your way inwards and then return false if one of them isn't equal to the other one. So let's just run it. Oh, it doesn't work for some of these. I guess this does have to be divided by 2. So now let's try it. No. Oh, I know what I have to do. This has to be a G here. So it gets rid of all the underscores and commas. So that's why this one wasn't working. It was just getting rid of the first white space and nothing else. But now it will get rid of all of them with the G flag. So now let's try it. There we go. There it worked. Roman numeral converter. For this challenge, we want to convert this number into its Roman numeral. So in the case of 4, it would be IV. In the case of 12, it would be XII. So let's get started with this. First thing I want to do is define our pairs. So what a number should equal for its letter. So we'll have let pairs equal an object of, we want I to equal 1 because I's equal 1, V's equal 5, X's equal 10, and M's equal 1,000. So we actually want to start with the biggest ones first. We'll go M equaling 1,000, C equals 100, D actually equals 500, L equals 50, X equals 10, and V equals 5. But just to make this a little bit easier, since if we have a smaller one in front, it actually subtracts from it, and we don't want to deal with that. So we'll actually just put in that value in here as well. So IV equals 4, and then we'll do the same for the ones in between here. We'll go CM equals 900. We'll go CD equals 400. XC equals 90. XL equals 40. IX equals 9. And yeah, that should be all the ones we need. Now what we want to do is have a while loop where num is greater than 0, then keep doing this loop. Right now num is 36, which is greater than 0, so it'll enter. And then we'll have our keys equal to object.keys, object.keys of our pairs. So that'll grab the letters M, CM, D, CD, C, and so on. And then we'll have our let letter equal to I to start off with. And then inside of here, we'll do a for loop as well. Let I equal 0, I less than keys.length, I++. Here, I'll console log the keys quick here. And actually, we could probably put this let keys thing outside of the while loop. So yeah, there's our keys, all of the letters. And then inside this for loop, we'll do if num is greater than or equal to pairs with keys of I. So that'll grab the actual number in this, and it'll check if 36 is greater than or equal to one of these values. So it'll start off checking with 1,000. 36 is not greater than 1,000, but it is greater than 10. So it'll keep going until it gets to 10. And then what do we want to do with it then? We want to have our letter equal to the X then. So to get the X, it's just keys of I. And then once we find it, we want to break out of this for loop. And then still inside the while loop here, we want our answer to be plus equal keys of I. And we want our answer to be a string up here. Oh, we actually want it to be answer plus equals the letter that we got, not keys of I. And then now, so that we don't get an infinite loop, we're going to take our number and we're going to subtract from it the pairs of letter, and then we're going to return our answer. And then I'll console log it here. So there we get XXXVI. Let's try 44. 44, we get XLIV, like it says here. And yeah, this is the solution for this one. Not too bad if we have all of these in here. If we didn't have these XLs and XCs and CDs and IV in here, it'd be a lot harder. But having them in there saves us a bunch of headache of having to like switch 3 I's for an I in front, and yeah, or switch 4 I's in the back for an I in front. Yeah. So just to go through this again, we have our letter set to I by default, but we change letter to the letter where the number is greater than that number. So in the case of 44, 44 is greater than 40. So it'll grab XL and it'll do answer plus equals XL. So now answer equals XL. And then we take our number of 44 and we subtract the 40 from it. So now number equals 4, and number 4 is greater than 0. So it'll do this again, and it'll grab the letter where 4 is greater than or equal to that number. So in this case it's IV, because 4 equals 4, and then it grabs that letter, which is IV, and appends it on, answer plus equals IV. So that's how we get XLIV. And it takes the number 4 and subtracts 4 from it, and we get 0 for num, and 0 is not greater than 0. So it breaks the while loop and just returns our answer. So let's run this test. Sweet. Caesar's Cipher. This challenge is all about cybersecurity and being able to encrypt and decrypt strings. And the way we do this is by shifting our letters by a set number of places. In this case, we're going to go 13 places. So an A will become an N, and a B will become an O, and a C would become a P, and so on. For this challenge, we want to decode this string. So the way we're going to do this is we're going to use the from char code method, and we're going to use the char code at method. So to get started, I'll just make a few comments here. 65 through 90 is the character codes for A through Z. We would want 90 to turn into 78 because 65 plus 13 is 78. We don't want it to equal 103. We want it to go back to the start and then add 13. And then we would want like 83, which is an S, to go to 70, which is an F. Okay, let's get started here. Let answer equal an empty string to start off with. And then we're going to do a for loop of let I equal 0, I less than string.length, I plus plus. And then we'll find our character code of this character. So what is S? Well, we're going to do let char at equal string of I dot char code at. That's the magic method that we need. That'll basically turn this string into its code. In this case, it would be 83. So now char at is 83. If char at is less than 65 or char at is greater than 90, then we just want to append that string, and we don't want to shift it at all because it means it's not A through Z. So we'll just do plus equals string of I. Otherwise, it means it is a character of A through Z. So we want our letter code, our new letter code here, to equal the character code before plus 13. We're going to do if the character code plus 13 is greater than 90, then we want to do modulus on it. So we'll do char at modulus of 26, because that's how many characters there are in A through Z. There's 26 letters, and then we'll add 65 on it. Otherwise, we just want to do char at plus 13. And then we can do answer plus equals. Now we have to turn our letter code, our new letter code, into its corresponding character. And the way we do that is with string dot from char char code, and then we pass in our letter code. And then at the end, we return our answer. And I'll console log it here so we can see that it works. And there we go, we get FreeCodeCamp. This string right here turned into FreeCodeCamp. So again, we get each character's character code. Then we make sure that it's an actual character of A through Z. And if that's true, then we check if the character code plus 13 is greater than 90. If it is, then we have to do modulus on it to get the remainder, and then add 65 to it to make it at least 65. But if that plus 13 is not greater than 90, then we can just return that to letter code. And then we decode that new letter code and append it to the answer, and that's how we get our deciphered message. So this one wasn't too bad. Let's move on. Telephone number validator. For this challenge, we want to make sure that the string that's passed is a valid telephone number. All of these would be examples of a valid telephone number. So this is a really hard regular expression problem, which I really don't expect anyone to get. And that's why we are going to use help. So we're going to do get help, get a hint. And it says like you should try these individually and do it that way. Tried to do that, still was having problems with it. So in the case of this, I would just copy the solution here. I know it's bad, but for regular expressions, there's always something that you can copy that's already online, unless it's something super simple that you need to figure out. I would say some standard things like making sure it's a valid telephone number or a valid email. You can find regular expressions to handle that just like by looking them up online, because who really wants to go through this and figure out what that means? Come on. I do know what some of this stuff means. It's just hard to come up with it on your own. But yeah, this should work for all of them, and let's just move on. This one is kind of disappointing, I guess. Alrighty, cash register. So this is the longest challenge in this algorithms and data structures projects. Yeah, basically what we want to do is we want to check, or we want to return the status of our cash register plus the change that is due. So in the case of our price being $19.50, and then them giving us a $20, we want to return 50 cents worth of change in quarters. So that's what this is saying. And we also want the status to equal open. In the case of them giving us a $100 bill for $3.26, we want to return our change. And you'll notice here that 20, we only have 60 inside of our cash register. Even though we could have returned 80 right away with the 20s, we only have 60 in the cash register, so we can only do a maximum of 60 here. Otherwise, this challenge would be a little bit easier. In the case of not having enough change inside of our cash register, we want to return insufficient funds with a change of empty brackets. In the case of not having the right type of change, so in this case they want 50 cents, but we only have 1 penny and one $1 bill, so we don't have the correct type of change. We have enough change, we just don't have the right types. Then we want insufficient funds with empty array of change as well. And then the last case is if we have exactly the amount that we need. So in this case we have 50 cents worth of pennies for their 50 cents worth of change that they need. And in the case of them being exact, we want our status to be closed and our change to be all of them for some reason. I don't know why. But yeah, let's get started with this one. First of all, we want our change to equal an empty object. That's what we're going to be returning at the end. And then we'll do change.status equals open by default. We'll do change.change equals an empty array by default. And then we will handle the insufficient funds case first. So first we're going to find the total amount of money that we have in the register, and I'm going to change this name to register here. So we'll do let total amount in register equal to math.round. This will just be for precision purposes. We're going to round our register.reduce, and then this takes an accumulator and the actual like coin, and we want to add up our accumulator plus our coin of 1. So that's saying get every one of these numbers and add them up. And then we want our accumulator to start at 0. And then again, for like precision purposes, we have to do times 100 here and then divide it by 100 at the end. This is just so that we don't get any weird decimals for this amount. So let's console log this quick and see what we get. So there, our total amount in register is $335.41. That's all of these numbers added up. Now we want our amount due in change. So we'll do a let amount due equal to math.round for precision again, which will be cash minus the price. So 20 minus 19.5 times 100 and then divided by 100 again. So now amount due will be 0.5. And then we're going to check if the amount due is greater than the total amount that we have in the register. Then we want change.status to equal closed, or actually insufficient funds, and then return change at the end of that. So in this case, we do have enough in the register. Here, I'll console log this too. So in this case, we do have enough in the register, so the status stays open. If we made this into 2000 here, or yeah, 2000, then we can see that we have insufficient funds to give to the customer, basically. Now we want to handle if we have the exact amount of change. So to do this, we'll do if the total amount in register equals our amount due. Then we'll do change.status equals closed and change.change equals our register, and then we'll return our change. Make sure this is a double equal here or a triple. Don't matter. Now if it gets past those two, we want to handle just giving them back the correct amount of change. So handle the correct amount. First we'll have an object of our amounts. We'll set 100 equal to 100, 20 to 20, 10 to 10, and so on. There we have our amounts. 10 is 10, 5 is 5, 1 is 1, quarter is 25 cents, dime is 10 cents, nickel is 0.05 or 5 cents, and a penny is 1 cent. So now what we want to do is we want to take our amounts and we want to map through its keys, or go through each of its keys. So we'll do object.keys of our amounts and then do for each on it. So dot for each, and then we'll do for each key. What do we want to do? We'll go if amount due is greater than amounts key, then we want to do stuff inside of there. But yeah, we're getting our amounts due from up here when we did cash minus price, and we're checking if that amount due, so in this case it's 50 cents. We're checking where the 50 cents is greater than these values here of 5, 1, 25 or 25 cents, and in this case 50 cents is greater than 25 cents. So that's when this would be true. To start off this if statement, we'll have a variable of amount of bill in register, started at equal to 0, and then we'll grab our register, so this huge array, do register dot for each on that as well, and we'll grab each type of coin and we'll do if that type equals our key, then we want our amount of bill in register equal to that type of 0 or type of 1. So what this is doing is it's grabbing our quarters in this case, and it's checking how money we have inside of our cash register. In this case we have 425 worth, so it'll set amount of bill in register to 425. Now underneath that for each, we want to do let amount due before equal to our amount due to start off with, and then we'll change our amount due to equal the amount due modulus our amounts of key. So what this is doing is it's grabbing our 50 cents that we have to give the customer, and it's doing modulus on that with the quarters of 0.25 cents or 0.25. So it's doing 0.5 modulus 0.25. So now amount due will equal 0. But also, because decimals are so weird with JavaScript, we want to make it precise again. We'll do amount due equals math.round on our amount due times 100 and then divided by 100. And now we'll do a variable of let difference equal math.round for precision purposes again, our amount due before minus our amount due now, do times 100 and divide by 100. And then we'll do if our difference is greater than the amount that we have in our register, the amount of that specific bill in our register, then we want to do change push on the key plus the amount of bill in register, and set our amount due equal to our amount due before minus our amount of bill in register, minus here. So let's go through this here. The amount due before will equal 50 cents, and then amount due will now equal 0 after we do this line. So what we're doing is we're grabbing the difference of those, which is 50 cents, and we're checking if 50 cents is greater than the amount of quarter in our register. So in this case we have 425 in our register for quarters, which is not less than our difference of 50 cents. So we actually don't do this line in this case. But let's say that we had just 0.25 here. If we had 0.25 there, then it would do this line. And then we would set amount due equal to 25 cents, because it would be our amount due before, which is 0.5, minus the amount that we have in our register, which is 0.25, and now amount due equals 0.25. And then we also push it on to our change array. Else, we want to just do change.change.push our key and our difference. So there we go, we're already getting pretty close. So in the case of getting 50 cents for the customer, we get 25 cents worth of quarters because that's all we have in our register. And then we grab 20 cents worth of dimes and 5 cents worth of pennies, and that equals 50 cents. Now we have one more case to handle, and that is the case of not having the correct type of change available. So the way we check that is if amount due at the end is still greater than 0, then we can just do change.status equals insufficient funds, and change.change equals an empty array again, and then we'll return our change. Amount should be amount due. So there we go, that should handle all of our cases. Overall, quite a bit of code to get this to work, but definitely pretty cool now that it does work. It handles all the cases that we throw at it. And let's try testing one of these quick, I guess. We'll check this one. So this is the one where we don't have the correct type of change. We only have ones and pennies, and it does this. Let's try this test. So we want to return 50 cents worth of quarters, and that's what we do. If we have 0 cents worth of quarters, then we return 4 dimes. Because we want 0 quarters, we want 40 cents worth of dimes and 10 cents worth of nickels. So yeah, actually it is working. I don't know why I thought it wasn't. I thought it was because I was confused why quarter was being passed in, but it's because a quarter is less than 50 cents. But yeah, this was it for this. Let's just run it. Oh wow, it actually doesn't pass this one. Thought it did though. Oh, this one. Oh, it's because I spelled insufficient funds wrong. We just need an I in there, and now it should work. Yep. Sweet. And that was it for those JavaScript algorithm and data structures projects. Next up, we have Introduction to the Bootstrap challenges. Bootstrap is for front-end development and for making our elements look a lot nicer and really quickly as well. It's basically a giant CSS file that we can use. Yeah, that's gonna be it for me today, and thanks for watching, and I'll see you in the next video.